Okay, for this video, we're going to be looking at replacing letters with numbers. So the title today, replacing letters with numbers. Now, if I have this figure here, we can see that we have a square, and I have split this square up into 9 littler pieces, or 9 little units to make it up. Now, if I look here, I can see that the length of this square is 3 units. Okay, our length is 3 units. I have 1 unit, 2 unit, 3 units. So I know that it's 3 units. So if I wanted to find the area of this square, I know that the area, capital A, is equal to S squared, where S represents our sides. So if I know that one side is 3 units, I know that the other side is 3 units. I can multiply those together. Again, I know the top side is 3 units. I know the bottom, or the other side is 3 units. So 3 times 3, or 3 units times 3 units, equals 9 units squared. Again, because I have units here, I have units here. So I end up with 9 square units, or 9 units squared. Now I'm going to clear this for a minute to look at our next example. So hopefully you already have this down. If not, pause the video. Okay. I have our square again. It's essentially the same thing, only this time I'm not breaking it up into little squares. I'm telling us that this side is 23 centimeters. Okay? So if I wanted to find the area of this square again, I would know that my area is the sides squared. And since it's a square, I know that one side is 23. The other side must also be 23 centimeters. So I have 23 centimeters times 23 centimeters. And if I multiply those together, I end up getting 529 centimeters squared. Again, 529 from the 23 times 23, centimeters squared because it's centimeters times centimeters, and I know that that means it's centimeters times itself, which would be squared. Now, in both of those situations, we replaced the S with a number. So we know that a letter represents one number in an expression. We knew that in order to find area, I needed to take my S, or the side of a square, and I needed to square it. Okay? Now, in each of those situations, that S was replaced with a number. In the first situation, that S, or side, was replaced with a 3. In the other situation, that side was replaced with a 23. Again, in both situations, those numbers were replacing the variable S. So again, S in the first situation was 3. S in the second situation was 23. 23 is one number. Now, 23 has multiple digits. It has 2 digits, a 2 and a 3, but it's still representing one number. So those letters have a special name. They're called variables. Okay, a variable is a symbol, like a letter, that is a placeholder for a number. So if we have a variable, we should be aware that we can replace that variable, we can replace that letter with a number to represent it. Okay, so letters can be replaced by numbers in order to represent, or represent either way. So let's look at this shape here. Okay, we can see this time I don't have a square, I have a rectangle. Okay, the first thing I need to see is what is going to be my length and what is going to be my width of my rectangle. So I can see that my rectangle is broken up into squares here. So if I wanted to find my length, I could say, okay, I have 1, 2, 3, 4, 5, 6, 7 units. So I'm going to say my length is 7 units. Okay, my width is now going the other way, so I'm going to have 1, 2. My width is going to be 2 units. Now, if I need to find the area of this rectangle. If I think back to maybe 5th grade, I remember that area is equal to the length times the width, or L times W. That L and that W are variables, and what I can do is I can replace those variables with what I know the length and the width are. So I know that the length is 7, I can replace it with the L. I know that my width is 2, I can replace it with the W. So that ends up telling me that instead of L times W, I could have 7 units times 2 units, which now equals 14 units. And that should be units squared, because again, 7 times 4 gives us our 14. Units times units, it would be units squared, because anything times itself is squared.